Good afternoon, everybody, in my physics classes. We have an interesting little question here on page 38, question 2 of the workbook from a couple of fellas. Today is the 27th of August 2021. The question is quite a tricky little one. What I've done is I've scanned in or taken a photograph and dropped it in here of the question. So light travels from one type of plastic with a refractive index of 1.8 to another with a refractive index 1.2 at an angle of incidence, actually this way, of 25 degrees. Well, it's hard to see, sorry. I'm not going to do them in the right order. I'm going to do A last. So when light goes from plastic 1 to plastic 2, will it speed up or slow down? Well, let's draw things up. So we're going to have plastic number 1, plastic number 2, call them number 1, number 2, put the refractive index there. There's refractive index for the first one, refractive index for the second one, so the refractive indices are there. Then we put in the normal and the incoming angle. I think it's this way. Yep. My screen's back to front for me. The angle in is 25 degrees. Cool. Now we come to the tricky little thing. The refractive index tells you how much light slows down. And here it slows down 1.8 times from the speed of light. Here it only slows down 1.2. So when it goes from here into here, it will slow down less. So therefore we're going to have the word speed up in there. And then when it speeds up, the beam will kick around away from the normal, so the angle will be greater. So speed up, greater. That's kind of cool. Now let's get busy. Sorry, I just draw in that thing there. So we're going to find this angle here, and I've drawn it kicked around a bit greater. Get rid of all that and move this up to the top. Right down in the Snell's law, I've reversed 2 and 1 from what we normally have. N1 sine theta 1 is N2 sine theta 2 because it fits with this layout here. Then I'm going to, what I want to do is find theta 2, this angle here all by itself, the angle of number 2. And it's cluttered up with N2 and sine done on this side. So to undo the multiply by N2, I divide this side by N2. But to keep the equal signs working, I need to divide both sides by N2. So this side's been divided by N2, and this side's been divided by N2 by putting it in, dividing it in there. And so therefore we're going to have sine of theta 2 is N1 divided by N2 sine theta 1 on this side. And over here we're just going to have sine theta 2. Then we want to undo the sine. To undo the sine, you do the inverse sine, or the calculator is the shift sign. Inverse sine of the sine is just the angle, which is cool. And the inverse sine of all this goes in here. Left-hand side, the inverse sine of the sine just becomes the angle, which is what we want. Now we can start putting numbers in because we've finished making this thing work. Now, N1 is 1.8, N2 is 1.2, and the angle is 25. 1.8 divided by 1.2 is 1.5. Sine of 25 is 0.4226. So multiply this by 1.5, you get 0.6339. And then you find the inverse sine, or the shift sign of this angle, and you get 39 degrees. And that's the answer in the back of the book. I hope this was useful to you guys. Cheers. Thank you.